Hello and welcome to another episode. Well, an episode. We're going to do a update on SpaceX's recent speech 5 days ago. A summary of it, of course. Now, basically what it is a design update of the BFG. Job done. Thank you all for watching and okay, no, I put much more work into that. The BFG is going to be a combination of the Falcon 9, the Falcon Heavy, and the Dragon 2. They tested its 12-meter tank. As you can see here, it has a 1,000 cubic meters of capacity. It is tested to 2.3 atmospheres, or 2.3 bars, and it has a new carbon matrix, quote, that's much stronger and more capable of at higher than anything before, end quote, Elon Musk. It holds 1,200 tons of liquid oxygen, and the RAPTOR engine was tested over 12,000 seconds of firing across 42 main engine tests. The longest test was 100 seconds, 40 seconds typical for a Mars landing, which is how long it'll last if they land on Mars. Test engines operate at up to 200 atmospheres or bars, and the engine's burn could last longer than 100 seconds, but their test tank isn't that big. The flight engine will be at 250 bar for the final design, and they hope they could get it up to 300 bar. They are trying to slow down the rocket without the help of the atmosphere, as there will be no atmosphere on the Moon or Mars, and they've been practicing landing with the Falcon 9. They had 16 successful landings in a row. Elon Musk thinks they could get the same landing rate as commercial airliners. And he hopes and, claims that they don't need landing legs for the next version, and it'll land in its launch mount. Now, the next section is about rendezvous and docking in orbit. They're going to launch the Dragon 2 next year. The Dragon perfected docking and heat shield tech, and they basically talked about the Falcon 1 and the company beginning. The day of the speech was the 9th anniversary of the first successful launch. The speech was on the 27th of September. Elon Musk had difficulties creating the Falcon Heavy. They thought they could just strap on two Falcon 9 first stages to the sides, but they had to redesign almost everything. The BFR will be fully reusable. Without mid-flight refueling, they expect to have a payload capacity of 150 tons, whilst the Falcon Heavy will only have 34 tons for comparison. The ISS is a football field long and it weighs 200 tons. That's a nice comparison. This shows the BFR. It has 31, as it says, it has 31 RAPTOR engines, and they produce a lift-off thrust of 5,400 tons, lifting the total vehicle mass of 4,400 tons. And I'm just going to circle this tiny person here for comparison. There you go. Keep an eye on that person. You'll see him in most of the next pictures, and I'll be referencing it. Okay, so this is the second stage, and as it says, the ship length is going to be 48 meters. The body diameter is going to be 9 meters. The ship dry mass will be 85 tons, and the propellant mass, which is the amount of fuel on it, will be 1,100 tons. It will be able, for max ascent, 150 tons, and if it is to return with a payload, it would be around 50 tons. The payload bay is 8 stories high, and it could fit some Falcon 9 rockets in it. Find that pretty interesting. The delta wings on the back is for balance with a pitch and roll control. Okay, so here shows the interior of the payload cockpit, which it's pressurized at 825 cubic meters, and it currently shows the Mars transport configuration, which has 40 cabins, large common areas, central storage, galley, and solar storm shelters. It can take roughly 100 people to Mars at a time, and here you can see there's the small person right next to the delta wing, and here it is. The fuel tank holds up to 240 tons of CH4, which it uses subcooled methane and liquid oxygen. So CH4 is methane. And the common dome separates the two chambers. The oxygen tank holds 860 tons of liquid oxygen. And the header tanks hold landing propellants during transit, which basically, if you land, it would be sloshing around the fuel wheel, so it's better to have a smaller tank, so you don't have to have 100 inputs all over the tank to take in the fuel. So yeah, and onto the next one, we're at the engine area, and the person's more obvious here, right next to the delta wing again. The chamber pressure is of 250 bar, as I said before. It could throttle from 20% to 100% thrust. It has 2 sea-level engines, which will be used for landing, and its exit diameter is 1.3 meters. The thrust, which is SL, would be 1,700 knots. The ISP SL would be 330 seconds, while the vacuum ISP would be 356 seconds. This has 4 vacuum engines on the back, which have an exit diameter of 2.4 meters, a thrust of 1,900 kilonewtons. Don't know what I said earlier, but it's kilonewtons, and an ISP of 375 seconds. Of course, these are vacuum engines, so these would be VAC ISP. All engines have a, quote, high gimbal range, end quote, and the BFG could only land with one sea-level engine if needed. They want it to be safer. Here you see a BFR docking to another BFR and transferring fuel to it. They use the same connecting parts as they used to decouple the first stage. They also reuse the fuel lines in docking that is originally used to transfer fuel between the two stages. Okay, and now we have some charts here, which is the rocket capability of orbit. Over here it has their original design, the Falcon 1 with 0.7 tons, the India GSLV 5 tons, 70 tons, 8.2 tons. Wait, did I say 70 tons? That's 7 tons. 8.2 tons, 18.8 tons, 19 tons, 20 tons, 22 tons, 22.8 tons, which is the Falcon 9, 23 tons for the China. The Delta IV Heavy will be 28.3 tons. The Falcon Heavy would be 54.4 tons, even though he said earlier it would be like 34 tons. Saturn V with 135 tons to low Earth orbit, and the BFR with 150 tons to low Earth orbit. Now, with a twist here, we have the launch cost, which, as Elon Musk said, it basically flips it. So the BFR is first, then the Falcon 1, then the Falcon 9, then the Falcon Heavy. All Falcons, except the BFR, but they're all made by SpaceX. The India, yada 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 yada. Okay, so Elon Musk relates the cost between a small $2 million biplane that is not reusable to chartering a fully reusable $5,000 747 to space. And now we have charts down here which basically shows the capacity of it with delta V, how much delta V it would have with what payloads, and it mainly shows the amount of delta V it has which with each refuel. Delta V is basically how powerful the rocket is. Let's say the heavier the rocket, or the less the thrust, the less delta V there is. It's all about efficiency, mainly. It's all about making the most efficient rocket and how far it could go. But moving on, with the BFR they could send something almost 9 meters wide into orbit, which 9 meters is 29, which a little less than 9 meters is 29 feet. They could send a telescope 10 times as big and powerful as Hubble telescope. They will be able to service the ISS and transfer crew and cargo to and from it, which I think this image looks a little funny on the comparison. The BFR would be able to fly to the moon, land, and fly back with only refueling once in elliptical Earth orbit. They could use the BFR to create a lunar base. As seen, the BFR uses a crane to lower its cargo to the ground. As you can see, the BFR will be able to land on Mars with a fleet of refueling rockets. And I might as well mention that Elon Musk plans to have a large stockpile of BFRs. The ship will have to refuel on Mars, but all the materials needed are naturally on Mars. The fuel on Mars will be made with complete solar power. They'll start their first construction of the BFR in around 9 months. Musk feels certain that they'll be able to launch it in 5 years. And now up is their goals. Their goals for 2022, which is all cargo missions, 2 cargo ships, will be to land at least 2 cargo ships on Mars, confirm water resources and identify hazards, place power, mining, and life support infrastructure for future flights. For 2024, cargo and crew missions. 2 cruise ships take first people to Mars. 2 cargo ships bring more equipment and supplies. They set up propellant production plant and they build up base to prepare for expansion. Okay, the first mission goal is to locate the best source of water. The second mission goal is to build up a solar-powered plant. After that, their plan is to build up the base. The base starts with 1 ship, then multiple ships, then they'll start making the city, then make it bigger, then they'll make it even bigger. Overall, they plan to make the base quite the nice place to be. And after all of this, they were thinking, well, we have this amazing place to go to Mars, so why don't we just, well, how do I say this? Why don't we just use it for transport like a plane? I mean, it's fully reusable like a plane, so why not use it as a plane? And they got some quite interesting results. Thank you all. I'll just run the video now. Thank you all for watching. Don't forget to like and subscribe if you do, if you enjoyed it. If you have any questions about this, I know I threw a lot of big words at you. Then just ask in the comment section and I'll do my best for clarification. Thanks again for watching. I spent the entire weekend on this, and goodbye.